Well, hi everyone. It's a pleasure to be opening this session on risk assessment and um, disaster management. So under this topic, I will be highlighting the current need and urgent challenge that policymakers are facing right now or currently facing. Which is the development and implementation of policies that help adapt and mitigate the effects of climate change, which is also part of one of the Sustainable Development Goals, the 13th. And at the heart of this goal lies the climate change vulnerability assessment framework, which is a integrative framework to analyze the effects of climate change and provide priorities of interventions in a territory. So today I will be talking about this and how to combine it with a approach, MCDA approach. This is a collaborative effort with between Claudio Garuti, Luis Bojorquez, and myself. And I would like to start with what is vulnerability. So in general terms, vulnerability can be seen as the state of the system that is differentiately impacted or affected by different drivers that are external of the system. And the response or the capacity to the response and change of the system would be called the adaptive capacity of the system. So with these general definitions, we can see that there are two different states of a system that can or should be addressed. Those are the adaptive or desirable state, which means a state where the system could adapt or could overcome the impacts of the climate change. And the second one would be the undesirable one, which we'll be calling the vulnerable state, which means that maybe the system could not recover from the impacts of climate change. So today, I won't be talking about how to define these states or how to identify them, but rather how to identify where a system lies with regards both states, if it's closer to an adaptive state or if it's closer to be a vulnerable state. So the questions that I would be addressing today are: what are the thresholds that delineate the adaptive and vulnerable states? How can we define or address these thresholds and the closeness to these thresholds? And which interventions are essential to prevent exceeding such thresholds? For this, I will be just presenting an implementation of the rate of change and center of gravity approach developed by Claudio Garuti and recently also published in collaboration with Enrique Mu. So I will be taking three important metrics from this framework. The first one is the local thresholds metrics that comes from the analysis of the rating scales from the ISAHP. The second one is the global threshold metric that integrates the local thresholds along with the priority weights. And these global thresholds are seen like the overall thresholds of a ISAHP or ANP model. And the third metric is the Garuti Compatibility Index, which allows to analyze the closeness to the thresholds. So this example will be shown, or I will be showing this through the 15 communities in Mexico which main resource of income is fishing activity. So they are fishing, small-scale fishing communities that vary not only with regards to the location along the coast of the Yucatan state, but also they vary in terms of their assets to be able to respond to the impacts of climate change. We developed this AHP model in consultations with a multidisciplinary team. One expert from political science, the second from fisheries biology, coastal management, and environmental policy. But they were all experts in fishing communities in this area of the territory in Yucatan state. So as you can see, the AHP model incorporated 3 specific drivers: economy, government, and society. And from them, sorry, the other drivers were developed as sub-criteria of these 3 drivers. So for each driver, price, employment, unemployment, market, policy, governance, law, processing, zoning, and surveillance, we developed the rating scales. And then we applied the local threshold equation. And this equation was applied for the medium and low categories and the medium and high categories. As we see that the medium category, sorry, is like the threshold for policymakers to analyze where to attend first. So you are seeing here the medium-high threshold profile, which incorporates the local thresholds from the rating scales. And in yellow, you are seeing the moderate low threshold. In blue, you are seeing the profile of the fishing community. And well, we analyze the closeness of this profile to the threshold profiles using the Garrote compatibility index. So not only in terms of the vector, but also in terms of each point of the vector in relation to the other profiles. Then using the difference between the Garrote index and the weight of each driver, we addressed the influence of the driver in terms of the vulnerability, the overall vulnerability for the community. So these thresholds and this profile is just for one community along the coast. For this community, the most influenced drivers were unemployment and law. So if sorry, if the stakeholders or policymakers change or intervene in the territory to change unemployment and law in this fishing community, then the overall vulnerability would change from one category to another. And in general terms of the 15 fishing communities, we had just 1 in low category, 3 in medium category, and the rest of them in a high category. And this was addressed analyzing the global threshold of the model. So for each community, we implemented this analysis, and we obtained this differentiation of, or this change of categories in all of them. So we now had in which fishing community to implement first the changes, and in which measure. And this is the table of the overall results. And this shows how this method can help prioritize interventions of different parts of a territory, and in which driver to attend these interventions in order to decrease the overall vulnerability. So in general terms, just to conclude, we address the three questions of how to identify the thresholds and how to prioritize the implementations of a territory. Thank you. I'm sorry because I'm a little bit sick, but I hope it was understandable.
Thank you, Tatiana. We have time for a couple of questions. Enrique, please.
Yeah, I wonder, this is a very extensive, application of the threshold theory for it. What, since this is a real case, what is the most difficult part from an application point of view in setting up this threshold?
The most difficult part of the analysis or of the implementation, you say?
Yeah, not the analysis, but the implementation, the development of the threshold, because you need to work with experts, etc. So I wonder if there are any practical challenges when implementing. Yes, I'm familiar much more with the theory than the actual implementation.
Yes.
Of the scale that you're doing.
Yes, of course. Thank you for your question. Actually, the most difficult part, I would say, was the integration of the AHP models, because I didn't mention here, because we had that on an extended analysis, but we made the consultations individually with the experts. And it happened that, well, they had opposite views on the priorities in the general drivers and also in the specific drivers. So I would say the difficult part is to make consensus out of these opposite views. When you are, in this case, the agendas of the stakeholders limits the possibility of having just one consultation with all of them. So we analyze all of the scenarios, so we don't miss any important thing by just selecting one view instead of another.
Thank you.
Thank you.
Any other question?